Thank you for your kind introduction. Hello and welcome to my talk. So I'm Yaroslav from Lightnovo, and at Lightnovo I am in charge of technical sales and applications development. I'll give a general talk about our company as well as our technology, give an overview of our product lines and applications. So Lightnovo was founded in 2019 by our CEO Alexey Ilchenko and colleagues. And unfortunately, Alexey is a very busy guy and he was not able to attend this conference, so I'm giving a talk on his behalf. So the mission of Lightnovo is to democratize the power of high-end Raman spectroscopy for the benefits of mankind. And by this we mean that we make Raman devices more affordable, more compact, without compromise of their performance. The headquarters of Lightnovo are located in Birkerød, Denmark. We as well have a branch, Lightnovo UK Limited, in the UK, as well as multiple remote employees working from Ukraine. So you probably already know this. This is the principles of Raman technology, but let's go again through it. So in Raman spectroscopy, the sample is probed with a laser. You can measure practically everything, solids, powders, liquids. You can probe through the container. Basically, you can measure everything except of metals. Then the signal is generated on the sample, and each molecule has a unique vibrational fingerprint. Here we have three different types of scattering: relay scattering without the change of laser wavelengths, anti-Stokes scattering, which is blue shifted, and Stokes scattering, which is red shifted. In our technology, we mostly look at the Stokes component. The signal is collected by the analyzer, the spectrometer, and the fingerprint spectrum of the sample is recognized by artificial intelligence and the substance is identified. So our key product is Mini Raman. Mini Raman spectrometer is a compact handheld spectrometer suitable for field applications. We also have Mini Raman microscope. So it's a modular system where Mini Raman spectrometer goes inside of Mini Raman microscope. Mini Raman microscope is also quite compact, so you can easily fit it in your backpack and travel with it. Another product line is RG Raman spectrometers and microscopes, and RG stands for research grade. Here we have more broader choice of laser wavelengths. So we can use lasers which are not available in compact form factor as in Mini Raman. And again, it's a modular system as well, where RG spectrometer goes inside of RG microscope. Another product line is TOR. TOR is an advanced Raman microscope where we can have up to 5 lasers, and actually there are no moving components, so it's easy to switch from one wavelength to another. As well, TOR has a polarization capability where we can change the polarization of excitation as well as look at different polarizations of scattered Raman signal. And it's useful, for example, in the field of crystallography, where instead of doing very expensive X-ray analysis on microscale, you can do that with Raman spectroscopy and determine crystallinity of the sample, orientation of crystallites, and stuff like that. So basically, what we want to do as a company in Raman spectroscopy, we want to do a revolution similar to that what has been done by smartphone cameras in the field of photography. So nowadays, hardly anyone is using expensive DSLR cameras in everyday life, and everybody is using smartphones for photography every day, and they are quite happy with the result. And we want to do the same with Raman. So the Mini Raman spectrometer, the advantages of Mini Raman are quick start, operation readiness 5 seconds, small size, it can be, for example, carried on a belt by the police or customs officer, low price starting from 10,000 euros, as well as high reliability. There is no need for recalibration, and I'll mention why. Mini Raman technology is protected by various international patents. Recently, we've also published a paper in highly ranked journal Nature Communications on the core principles of mini-Raman technology. The key feature here is the presence of inbuilt polystyrene reference channel. This allows us to use smaller, less expensive lasers without thermoelectric cooling. So basically, as you can see here, the calibration is the X and Y calibration. So the intensity-wise and spectrally-wise is performed in real time. And we can get very stable Raman spectra, as you can see here, even with unstable lasers. And this is due to the presence of reference channels. So basically, every spectrum, every acquisition is corrected and recalibrated in real time in the embedded software on a device. And you already get corrected data. So we have various different mini-Raman models. Mini-Raman standard with one laser, 785 nanometer. We have mini-Raman power with enhanced power specifications. We have mini-Raman SERS, which is well tunable in low power range. As well, we have duals. It's to expand the spectral range because the mini-Raman standard goes from 400 to 2700 wave numbers, basically covering the fingerprint region. But with the second channel, you can go up to 4000 wave numbers. Recently, we've developed also full range 665 nanometer spectrometer and 830 nanometer spectrometer, so it's not mentioned in the slides. We have multiple different accessories for mini-Raman. So the probes with different working distances, starting from the touch probe to short distance probe, middle distance probe, like 1.5 centimeter, and so on. Accessories for the measurements in liquids, in powders, and we have actually a YouTube channel, and then over there you can check more detailed specifications and demonstrations of all these accessories. Recently, we've developed a standoff accessory with a working distance of 1 meter. And this is especially useful when we measure hazardous substances and explosives. So we've also put mini-Raman on a drone. This allows to send mini-Raman to red zone of danger where humans cannot operate, very dangerous, and then can do remote sensing there. So mini-Raman microscope, I already mentioned it, so it's like, again, protected by other international patents, ultra compact, robust, and as you can see, it's shown that it's modular system. Mini-Raman spectrometer goes inside of mini-Raman microscope. We have a whole ecosystem of the software, MirrorSpec software. So the software is available on the device, so embedded Linux software. You can control mini-Raman or other spectrometers from mobile phone, from tablet, and as well there is a desktop application. So the use cases for mini-Raman. At the moment, we are mostly interested in, we're mostly focused on the defense and security applications, so detection of toxic gases, chemical weapons, explosives, illegal drugs, hazardous liquids, but as well as have more civilian applications, bacteria identification, microplastics, polymers, art conservation, minerals, skin analysis, plant analysis, food analysis, and so on. So here are the list of some end users and their application cases. Unfortunately, I cannot name the companies and organizations because with many of them we have NDAs. But for example, in Sweden and in Spain, they are measuring toxic gases. In Italy, they are doing some plant research with mini-Raman. Then we have multiple users in Denmark, since we come from Denmark. Then in the UK and Ireland, they're using mini-Raman and other spectrometers at the universities for teaching. There are some space applications in Canada. And for example, in Australia, they're using our spectrometers for concrete inspection. So basically, we're open to collaboration, and thank you for your attention. And last but not the least, thanks to the organizers of the conference for inviting us here and giving an opportunity of being a sponsor. And you're welcome to our booth. We have the devices there. We can perform live demonstrations. Thank you.